All right, let's talk about significant figures, both determining the significant figures and using those significant figures in calculations. Remember that significant figures come from measured values, not conversion factors necessarily, or exact values. First of all, the rules of significant figures. The rules are all non-zero digits count. Okay, so just non-zero digits would be like 457. We've got 3 sig figs there. 35, 2 sig figs. The number 5, 1 sig fig. Leading zeros do not count. 0.005, I've got 1 sig fig here. 0.0023, I've got 2 sig figs. Okay? Again, leading zeros don't count. Confined zeros do count. 202, 3 sig figs. 50571, I've got 5 sig figs. Okay? And then the last one, which is a little bit ambiguous, trailing zeros count if there's a decimal point. And so we have to look at the number 30.00, 4 sig figs. 30 has 1. 25,000, 2 sig figs. No decimal point. 25,000 with a decimal point, and I've got 5 sig figs. So be careful with that. Look out for that decimal point. All right, so let's try a little counting down here. Let's see what we can get. How many sig figs in each of the following numbers? Well, this first one, 36,000, I'm going to say 2 sig figs in that one. There is no decimal point, so the trailing zeros do not count. Here I've got 2 numbers. I've got a 1.85, which gives me 3 significant figures, and then a 105, which is also 3 significant figures. Okay? Confined zeros do count. Here I've got a leading zero, which does not count, and then I've got 1, 2, 3 sig figs. And here I have a decimal place with a trailing zero, so 3 sig figs. And here I have a decimal place, 4 non-zero digits and 2 trailing zeros. The trailing zeros count because there's a decimal. So I've got 1, 2, 3, 4, 5, 6 significant figures here. So counting sig figs. When you're doing calculations now, this is where you utilize the sig fig counting. When you're doing calculations, your calculator may spit out a number that looks something like this. 6.038 times 2.57, and you get 15.51766. And the question students often ask is, should I write all those numbers down? Should I write 2, 3, 4, how many? Well, the answer is in the rules of significant figures. In multiplication division, the measurement with the fewest sig figs determines the number of sig figs in your answer. And so here I've got 4 sig figs, and here I've got 3. Okay, so I can only have 3 sig figs in my answer, so I'm going to call this 15.5. And here I've got a series, in the next example, I've got a series of multiplication steps. Each of these is 3 sig figs, so I should have 3 sig figs in the answer. This time the calculator number is correct. 216, 3 sig figs. Okay. Here I've got one where I've got the same type of calculation, 3 multiplications, but I've got 3 sig figs, 3 sig figs, and then remember leading zeros do not count, so there's only 1 sig fig here. So I'm going to have to drop my answer down to 1 sig fig, 2. Here I've got, in my last example on this page, I've got the multiplication in the numerator and then divided by 3.15. I've got 4 sig figs, 4 sig figs, and 3 sig figs. The weakest link is the 3 sig figs, so I'm going to want to cut this off here, and so my answer 3.12. Okay, so multiplication, division, the measurement with the fewest number of sig figs gives you the number of sig figs in the answer. Okay, most people have very little trouble with that. In addition and subtraction, we have a different set of rules. Here we have to look at the fewest digits to the right of the decimal place. That's how many digits to the right of the decimal in your answer. So let's take a look at these and see what we can do. Here we've got 10.2 plus 3.4 plus 6.01. Now this time, because it's an addition problem, I'm not going to count sig figs. I'm going to say how far past the decimal do I go. Okay, well, as far as I can go is to the first position, because I've got these two that only have one place past the decimal, so I'm going to have to cut this off and call it 19.6. Now the next example is a subtraction, and I'm subtracting 9.1 from 10.210, and the answer is 1.11. However, in the first number, the first quantity, I have 3 places past the decimal. In the second quantity, I only have 1 place past the decimal. So 1 place past the decimal is as far as I can go. I'm going to have to call this 1.1. Adding and subtracting. Now occasionally you're going to run into a problem where you're not just multiplying, dividing, not just adding and subtracting, but some combination of the two. And so here's an example where we're going to take 27.3 and we're going to multiply it times this difference. Well, the difference needs to be done first. And so even though I have 3 sig figs, 5.51 and 4.75, the difference, 0.76, has 2 sig figs in it. Okay, all we get out of this is 2 sig figs. So when I multiply 0.76, which is what this difference is, times 27.3, I'm only going to have 2 sig figs in the answer. And so my answer correctly is 21 here. Okay, so how to handle that when you have a combination problem where you have both multiplication and division and addition and subtraction.